My project for systems thinking is on the electric car. First, we'll take a look at the two Chevy cars shown in the picture above. The Volt, the electric car, and the Malibu, the gasoline-powered car. We can compare these cars based off the 5 most important characteristics according to Paul Graf's book, Technology in the Modern Culture. Here we see the Malibu outperforms the Volt in 4 of the 5, which makes it the more valuable car to the consumer. Next, we'll go for the classification of electric car. The car is physical because it can be touched and requires a driver to move. Also, it is man-made because we produce the car, and non-living because it is an electric machine which we have control over. Here's a quick clip off Fox News that shows the recent failure of the electric car.
May be preparing for bankruptcy. The company is backed by the United States Energy Department. That means, of course, taxpayers, and they could be on the hook for $192 million. And today, Bloomberg News tweeting, Fisker Automotive said to fire 80% of staff.
It's crazy how easy technology can fail these days. However, let's take a step back from that and look at the systems boundary diagram of the electric car. On the left side, we can see the inputs, such as the using electricity. Inside the box, we can see the subcomponents of the electric car, such as the battery, the wheels, the license sensors, and so forth. Then you can see on the right side the output, which is movement of the car. However, if the movement of the car does not happen, there is usually internal feedback which is received, such as malfunctions, failures, or parts breaking. If any of these happen, there will be an error kicked back and the car will not move and will need to be fixed before it can move on. Once all those errors are fixed, we can receive external feedback, such as how the car works, complaints, and user problems. Once that is received, the car will be adjusted based off of that. Next, look at the systemagram for the electric car and see what really goes into it. So here we can see the company makes the design, and the design breaks down into what people want, and then we can go to operation system, and that goes into how the cars actually run, and then as we see at the end, how it connects all together is if the electric car fails when it does not meet the wants by the people, or the operation system does not work, and the workers and machines cannot produce stuff fast enough. Next, we'll look at the visibility as we see the electric car. We see the electric car through gray box visibility. We classify this as gray box because we know how the product is made for the most part, and we have insight into seeing how it all operates. However, we do not have specifics on how the car is made, such as the battery, or how it all actually works underneath the hood of the car, which only the makers actually know. Next, we'll go into the spatial arrangement of the car. First, we can see that instead of it being a gasoline spot, there's a spot to plug in the electric car itself. As you can see, there are the prongs which we plug the port into to charge the car. Also, we can see under the hood, there's a lot that goes underneath the hood. Even though there's not technically an engine, there's a motor which is connected through all those cables to make the car run. It connects ultimately through the battery, as you can see in the picture above, and it helps to understand it by really seeing that the green cables underneath connect to the floorboards, which go into the motor and ultimately make it run. As you can see here, circled in the picture, this is really the operation system and where all the work happens to make the car run. Here's a quick overview of the spatial arrangement of the electric car. First, we start with the mega system, which is known as the car company. And the system we are looking at, the electric car. Given that there's a lateral system, the gasoline car, then we can break down into the subsystems, the electricity, the drivetrain, the interior, and the exterior. Then we can break down to the elements and see what actually is inside the subsystems, as shown in the slide. We will now move on to the evolution of electric car. Electric car was first made in the early 90s and is evolved and is still being used today. Here's a quick clip showing the evolution of electric car. In the late 1890s, British inventor Robert Anderson and his co-founder William Morris, a chemist who lived in Iowa, were able to create the first 6-passenger vehicle which exceeded a speed of 14 miles per hour. This was deemed as the electric wagon, which helped electric cars spark in the later centuries. In the early 1900s, electric cars started to pop up across the U.S., mainly in New York City with a fleet of 60 as electric taxis. In the 30s and 60s, the cars were deemed dead because the need for electronic transmission has died and gas power was more sustainable. In the 70s, the gas shortage created a resurge in the need for electronic cars, thus GM produced one. 1990s, California passed a zero emissions test, which meant that all cars had to produce zero emissions. By trying to enforce this, they made electric cars. However, the electric car didn't really catch on, and as a result, they cut their losses, crushed most of them, and ended up impounding them for scrap. Again, in 2000s, once California got rid of the act, electric cars seemingly died. And why was this? Many may ask. Once again, in the 2000s, the resurge of cars came out again, and companies like Ford, Tesla, Mitsubishi's, etc. kept expanding and broadening the horizon of electronic vehicles, and thus trying to create another reason to have them. However, it hasn't really caught on yet. Next, we'll get into the system's life cycle and start with stage 1. We'll start identifying the problem here, which is the high CO2 in the air. As a result, we need a new means of transportation. The stakeholders here are the companies who are making the cars and putting the money into the car. The requirements of said companies is to lower CO2 and make mileage capabilities more successful. Some risks that can be seen here is initial risk, as the car may not be wanted, and cost risk, as the putting too much money in the car trying to establish the car around a concept of lower CO2 emissions will be a hard task. Moving on to the next step, step 2 and stage 2, which is develop the system's concept. Here we will refine system requirements to achieve lower CO2 emissions and meet the consumer's wants. We then explore system concepts of the car and develop feasible ones to focus on, such as mileage, power, reliability, and user-car interface. After the feasible system concepts are proposed, we can see programming risks possible, such as the car is not going to meet the requirements that were promised and could end up failing. There also will be cost risks, in that the car is costing too much to design, and as a result, it's going to cost too much and draw users away from it. After identifying risks, we try to refine them. Here we can see the biggest risk, technology, because if the car is designed to run off technology and there's very technical needs of the car, if it cannot be achieved, the car will fail. We then move on to stage 3, which is design and development. Here we will define the final concept of the car, and the company will make final model for the consumer's wants and requirements, as been said. They will make an initial cost of the car based off what they think it will cost and try to attract people to the electric car market. There are risks such as, once the car is in the final stage of development, the real price will be determined, and there is the cost here with the product being too much and not meeting the initial costs slated by the company, and will in turn draw users away. We also see business risk, because if the company has put all the time and money into the car and cannot turn a profit, as Pfister did, it will fail. Next, the company will perform development tests to reduce risks, refine performance, and identify any risks, and adjust schedules to minimize risks. The key to minimizing technological risk here is by making sure the battery doesn't die and make sure all the components of the car run smoothly. This will be the final step as they make adjustments in the development of the car and get ready to produce the car. The next stage, stage 4, is producing the system. Producing the system needs to be done according to design specifications and meet program schedules, such as the car's specs being pushed out and the specs being met. If they are not met, this can be seen as a programming risk, because not meeting the specs will draw customers away and in turn away profit. The business can be at risk for being uncredible, and that can affect their overall performance of business. Next, they try to refine any possible risks they see, such as technology of the battery. Once they think they have refined all necessary parts and operation the systems of the car, this will complete the cycle. Next is stage 5, deploy the system. Here we will refine operation, risk, and management, and develop a plan. We'll develop a plan by determining how many cars we'll put in the market and how many will be produced. When the system is deployed, the goal will be to meet the consumer's needs so the car can sell. They will show the car and show how it works to the user so the user can interact with it comfortably. Next, we see operational risk here, such as something in the car breaks or is deemed worn out, and the company is to recall the cars and replace them all. The goal in this cycle is to sell the car while lowering operational risk so there is no problems and the cars are in high demand. The next stage is stage 6, operate the system. Here they will monitor, measure, and mitigate operational risks that have been found in the stage prior. They will then provide sustainable equipment and maintenance times to update any of the operational system that does not work in order to enhance the system. Stage 7, and the final stage of the system's life cycle, is retirement of the system. Once the car is deemed dead or not wanted, the car will be put into retirement. This will be hard for electric car because of all the batteries in the cars that will be disposed of. This will not be an easy task, so retirement of the system will probably be the longest part of its life cycle. And lastly, we have innovation of the electric car. The only real innovation of electric car thus far has been by Tesla, who's working on bringing battery capabilities better and the style of the car. The only real innovation that has came from electric cars is a spin-off in the early 2000s, which was made as a hybrid which contains both electric and gas. And lastly, my references are shown here.